this is Susie, and this is the third in our series on linear functions. This is the one about quantifying gradients. So, quantifying gradients. We've already looked that gradient is a measure of steepness, but it's also a measure of how much one variable is changing with respect to another variable. Very important in economics, and much more on that later. A little bit of notation: slope, gradient are the same thing. Economists tend to use slope a lot, but you don't care, they're the same thing. Just before we start, you need to remember which one's y and which one's x, because we are going to use y and x a little bit when we talk about gradients, and you'll see economists use that as well. So we need to remember that y is the vertical dimension, the vertical axis, and x is the horizontal axis. And if you have trouble remembering which one's which, maybe you could use this to remind yourself. There's x. What's x? Well, it's across. So that helps us think of that x is the dimension that goes across, and the other one is up and down, so that must be y. So y and x. It turns out that gradient is measured as a ratio of the change in y over the change in x. So we calculate how much y has changed in a particular interval, say from there to there. We can see that y has changed by 1, 2, 3 units. Don't know what the units are. And x has changed by 1, 2, 3, 4, 5 units. So the ratio of the two gives us a measure of the steepness. So here it is. Gradient is the change in y over the change in x. It's also, you could also think of it as the vertical change over the horizontal change. And remember, when I keep saying over, I'm talking about a division. So let's calculate this gradient. The change in y is 1, 2, 3, divided by the change in x, 1, 2, 3, 4, 5. And it doesn't matter where on this graph we go, the gradient will be the same everywhere because it's a straight line. So it turns out that the gradient is 3 over 5, or we could think of it as 0.6. Okay, so the change in y over the change in x, or the vertical change over the horizontal change. That is by definition the rate of change. So here's 3 lines. Let's see if we can work out what the gradients are. Well, here we can see this one goes through a corner. Nice to look for where they go through corners because you can read them better. There and there. Say, it doesn't matter which 2 points I pick, but let's say when the function goes from there to there, the change in y is 2. You see, it's gone up by 2, but the corresponding change in x over that interval is only 1. So the gradient of that is 2. You know, I can see that it's going up 2 for every 1 across. I could look there. There it went up. So if we look at this point here, the change in y was 6, and the change in x is 3, but it's still 2. It doesn't matter where you do it. What about this one? Well, it would be convenient to look from there to there, and the change in y is 3 over the change in x, which is 1. Remember, it's the change in y over the change in x. What about here? Well, if we look between there and where it next goes through a corner, the change in y is 2, 1, 2. Yeah, it's gone up 2. Doesn't matter if you look there or there, it's gone up 2. Divided by the change in x, which is 1, 2, 3. So that this line is much less steep. Remember, the bigger the number, the steeper. We can see this is a bigger number, so we expect it to be steeper, and indeed it is steeper. But what about here? This is measuring miles travelled relative to gallons of gas left in the tank, remaining gas. So when we're looking at the change of y here, change in y over the change in x, y has changed from 4 to 2 over this interval. So that's a minus number. That's minus 2. From 4 to 2 is minus 2. It has dropped from 4 to 2. Must be negative. Divided by the change in x. X has gone in that interval from 0 to 40. which means the gradient is 1 over 20, which I think is, but your calculator will tell you that. And we use gradients as fractions or decimals, it doesn't matter. Here's a couple more negative gradients. So a reminder here that if we're going down, the vertical change is negative. The change in y is negative. Yeah? Positive, negative. We have to learn to recognize those slopes. When it's pointing downwards, it's negative. So here's a couple of functions which have negative gradients. So let's look at this one. What's the change in y? Let's go, say, from here. Well, it doesn't matter where we go. We can go from there to there. So in that interval, y has changed from 8 to 0. Yeah, it started at 8 and then it came down to where y is 0. So that's a -8 change to y. Whereas the x value from there to there has gone from 0 to 4. So -8 divided by 4 is -2, as your calculator would tell you. Here's another one. Let's say this time we'll look from there to there. It doesn't matter. I go from there to there, there to there, it doesn't matter. So in that interval, the y value has changed from 6 to 3. So it's gone down by 3. But in that interval, x has gone from 0 to 1. Yeah, it's gone from there to there. -3. And so here's 3 more. Let's see if we can find the gradients of these. So let's remember we're looking for the change in y divided by the change in x. So on this one, let's look. So the function went from there to there. Now, the y value from there to there has gone from 2 to 5. It's gone up by 3. The x value has gone from 0 to 2. So that's a gradient of 3 over 2, or 1.5. What about this one? Well, this one, shall we start from there and say go to there? The y value has increased from 0 to 3. So it's 3 divided by, and the x value has increased from 2 to 3. Yeah, so we're interested in that difference, that difference. That difference divided by that difference. What about this one? Well, let's say we go from there to there. The y value has gone from 7 to 4 in that interval. So that's a drop of -3. And in that interval, the x value has gone from 0 to 1. So it's a gradient of -3. So how about this one? Let's see if we can find the gradient of each of the red lines. A. See, now we can't count squares, but it's okay because we can look at the values, which this is more like you'll be doing later when you're analysing functions in economics. But this is fine, this is easy. So let's look at A. What's the gradient of A? Well, the gradient of the y value of A has gone from 0 to 75. And the x value of y has gone from 0 to 20. So it's just 75 over 20, which simplifies to 15 over 4. B. Well, this one, the y value has gone from 0 to 45. And the x value has gone from 0 to 60. Which I think is 9 over 12. C. C, the y value has gone from 0 to 30. The x value has gone from 0 to 80. D. There is no D. C, D, E. Right. So the y value of E has gone from 0 to 90. But really interestingly, what has the x value changed from? From there to there, well, the x value has not changed at all, has it? Because it's a straight vertical line. So the change in x is actually 0, which gives us a bit of a problem mathematically. If you put that in your calculator, which I encourage you to do, you'll get an error. Because you're asking how many times does something infinitesimally small go into 90? Well, it's an infinite number of times. So we tend to think of it as infinity. Finally, what about f? Well, the y value of f hasn't changed at all, has it? It started at 0 and it stayed at 0, the y value. So it's 0 over, but the x value has gone from 0 to 120. And how many times does 120 go into 0? It goes 0 times. So that's a valid gradient. In fact, gradients of 0 are very important to us, as you'll see later. So now try these ones yourself, freeze frame it, and I'll put the answers up. So here are the gradients for those lines. Now see if you can come up with the equations for these lines, as we learned in the previous video. I've done the first one for you.